Good morning, good afternoon, good evening from wherever you're joining us. My name is Megan Leese, and thank you for joining today's live stream event. We are excited to discuss updates with you about our new Terraform Cloud announcements. Joining me today is HashiCorp co-founder and CTO, Armon Dadgar, and Kyle Ruddy, Technical Product Marketing Manager for Terraform. During our session today, we'll jump into our latest product announcement, see a live demo, and then have that followed up by Q&A. This webinar is being recorded and the recording will be made available after our post-processing. That is usually within 2 business days. And lastly, please type your questions into the question box and we will answer them during our Q&A session at the end. And with that, we'll go ahead and get started and jump into it. I will turn it now over to Armon.
Awesome. Thanks so much, Megan, and welcome everybody. Thanks for joining us for today's live stream. I think Megan beat me to it. My name is Armon Dadgar. I'm one of the co-founders and CTO at HashiCorp. In just a little bit, we'll have Kyle join us, and he's going to give us a live demo of some of the new features and capabilities that we'll be talking about. So with that, let's jump right into it. For folks who are maybe less aware of HashiCorp, as a brief overview, really HashiCorp is focused on cloud infrastructure automation. And we mean that in a very broad sense, right? So part of our focus is with tools like Terraform, which we're talking about today, really focused on how do we provision and manage the life cycle of infrastructure from day 1 creation and stand up through day 2 needing to patch or reconfigure, day 3 scale up and scale down, to sort of day N when we need to decommission and take something out of service. Tools like Terraform, tools like Packer really focus on that kind of provisioning piece of the cloud infrastructure. Then we have other tools like Vault, which really look at how do we secure a modern cloud infrastructure. So this is everything from low-level infrastructure security, how do we protect underlying access to SSH keys, RDP, service accounts through middleware like databases, message queues, cloud APIs, etc., things that our applications depend on as middleware, all the way up to high-level data protection. How do we encrypt data, tokenize it, manage data in transit, secure data at rest, etc. So really looking kind of the broad spectrum of cloud security challenges and really moving into doing it in a modern identity-driven way, right? We look at the networking challenges of going to cloud with a tool like Console. So as we move from relatively static host-based, IP-based networking, where you might say these 50 machines are always an API service, or these 5 IPs always represent a database, sort of a modern landscape where it might be containerized. You might be using tools like Kubernetes, where applications are multi-tenant, they're much more dynamic, they're coming and going. And so really it's a shift to thinking about service networking as opposed to kind of traditional host and IP networking, where I want to route to the billing service, the web service. That might be a container on Kubernetes, might be a traditional VM, might be a mainframe, might be a new serverless application. So really looking at that set of challenges with Console in terms of how do we automate the network, right? Our load balancers, our firewalls, our API gateways, but also how do we do next generation service mesh and go sort of zero trust end-to-end TLS, right? And lastly, looking at things like how do we actually run our applications? So with Nomad, we really look at whether we're deploying a VM, a container, a serverless type application, whether that's on Windows or Linux or Mac, whether it's in one data center or multiple data centers. What's the developer workflow to support deploying apps, scaling up and down, canaries, blue greens, things like that. And then Vagrant, sort of tried and true, looking at how do we run our apps locally so that we make sure we have that sort of dev test parity, right? We're developing in an environment that looks like our production environment. So kind of thinking about HashiCorp holistically, we look at the broader set of challenges in terms of delivering a modern cloud infrastructure and try and solve it with a portfolio of different tools, right? The company itself is now going on about 8 years. We crossed an exciting milestone over the last week or two into 1,000+ employees, and we've raised almost $350 million in terms of our total lifespan. And I think this is really not a surprise. The area we spend the most time with users and customers is this migration to cloud, right? Obviously, our focus is really on cloud infrastructure automation. Part of that includes accepting and sort of recognizing the reality that for most large organizations, their private cloud or their on-premise environment isn't going away anytime soon. So the modern landscape really does look like, great, we have our existing on-premise estate, our private cloud. but we're also going to leverage one or more public cloud vendors, right? AWS, Azure, Google, Alley Cloud, etc. And so how do I actually do this in a consistent way, right? How do I modernize my delivery on premise? How do I do it sort of right from the beginning in cloud? How do I network and connect all these pieces together? And so that's really what the HashiCorp focus is delivering these workloads in a consistent way, whether you're on premise, whether you're cloud, whether you're multi-cloud, it's providing a consistent workflow that spans all of these different layers, right? So with that, I want to spend a little bit more time on Terraform today and go into a bit of what Terraform is for people who might be less familiar, and then go into the new capabilities that we're announcing. So Terraform at a very high level is designed to provide an infrastructure as code approach to managing all of our infrastructure, right? And when I say all of our infrastructure, this could be cloud-based, right? So it could be the major public clouds, AWS, Azure, Google. It could be low-level hardware on-premise, right? It could be a hardware firewall, a hardware load balancer. It could be literally a bare metal server that we're provisioning. So we can go down to the hardware level, but you can also go up the stack and manage things like platforms as a service. So Terraform is very commonly used to manage platforms like Kubernetes, as an example, right? So you think about a PaaS as being developer facing, but how do we provide a consistent infrastructure as code way to declare what workloads go on Kubernetes? How should they be orchestrated? How does that get tied into things like provisioning an RDS database that an app might depend upon, right? So with Terraform, you get a consistent way to manage all that, and then all the way up to very high level software as a service. So this would include things like Datadog and PagerDuty and services that are entirely hosted outside, right? I think the challenge, even with these very high level services, of course, you're not responsible for operating them, right? It's a software as a service, so that's sort of outsourced to the vendor. But how do we make sure that the configuration, right? As I deploy a new application, for example, am I defining a Datadog dashboard and an alert? And am I creating a PagerDuty alert that's linked to that? Can I do all of that programmatically as code so that A, I don't have to worry about human error where I deploy my app and forget to set up the alerts or forget to set up the dashboards for it, but B, it can be consistent. So if I have one app, not so much of an issue, but I get to 5, 10, 50, 100 applications, I ensure there's a consistent way that we're monitoring and alerting all of these things, right? And so you can think about Terraform as really being a tool for doing lifecycle management of infrastructure, always driven through an infrastructure as code approach, regardless of whether it's low-level hardware all the way through to high-level SaaS, right? And so where you see that really shine with Terraform is we have over 300 providers in our ecosystem, right? So a provider is really the glue between Terraform and some outside APIs. So AWS is a provider, Azure is a provider, et cetera, right? So it covers quite a breadth of different services and solutions that you can integrate with Terraform today, and that list is growing constantly, right? In terms of the community size, Terraform does well over 100,000 weekly downloads and continuing to grow rapidly. Our global community of HashiCorp user groups is over 30,000 members and spans, I think, over 200 chapters around the world. So if you're interested in getting plugged in, tends to be a bit more of a physical event. So once we're back to sort of a post-COVID reality, but definitely a great community that you can get locally plugged into. So that's Terraform, the core kind of a tool. Then as we sort of talk about Terraform Cloud and Terraform Enterprise, it's really around how do we provide a central platform, a central control plane that you can connect all of your different services to. And the analogy I like to use is Git and GitHub, right? With Git, yeah, everyone installs it on their laptop. You have it locally that you're interacting with. But if you want to connect it to webhooks and connect that to your CI system and your other third-party systems, you do all of that through GitHub, which provides a central management platform to wrap all of that. So the analogy here is the same thing. Terraform is the tool you're installing and using locally. Terraform Cloud or Terraform Enterprise is that collaboration platform. And so what it lets us do is integrate with version control systems like Git or GitHub, GitLab, Azure DevOps, etc. Various IT management systems like ServiceNow. You can connect notifications to systems like Slack. Maybe you want to integrate it to your CI/CD system, and so on and so forth, right? So it provides a platform through which we can do all of those kind of webhook and API-based integrations rather than sort of the desktop client, which makes it sort of difficult if you have a team of people trying to collaborate, right? So that's really the goal of these platforms, is how do we make it really, really easy for you to do everything through a single workflow, but then connect it to all the other tools that exist in your ecosystem that you're already using. Sorry about that. And so when we talk about kind of Terraform public users and customers, it's an enormous list of folks. Like I said, we're at 100,000 downloads a week and constantly growing. And so this spans everything from, small startups, 2 people in their garage, all the way up to some of the world's largest organizations like, Barclays Bank and SAP and PayPal, right? So it's an entire spectrum of folks from, small to large, from very cloud native to sort of more traditional and, long-lived businesses. And I think what it really speaks to is sort of the prevalence for and demand for things like infrastructure as code. So if we talk about the evolution of Terraform Cloud itself, this really grew out of our enterprise product. And so several years ago, at this point, May of 2019, we first introduced the ability for Terraform Cloud to be used for free to do remote state storage for Terraform. So if you were executing Terraform locally and you didn't want to deal with state files, you could use Terraform Cloud to provide that state file management, right? So you could sign up for a free account and just outsource it to us, and then you can have multiple people collaborating with Terraform without really having to worry that, if Alice is making a change, that she's going to step on a change that Bob is trying to make, and that those state files start to conflict. Terraform Cloud provided sort of locking around those, versioning around those, and coordination to ensure that you can have multiple people collaborating on a single state in a way that would be safe and consistent, right? So flash forward a little bit to September. What we did is we actually opened up the platform for more capabilities, not just the state management, but actually bringing in more of the collaboration features as well. So this included integration with version control systems, the ability to actually run Terraform through Terraform Cloud, comment on it, manage the actual workflow through the system. And then earlier this year, we introduced a set of features really designed to go from a handful of people to a larger team setting, where you really needed team management features like role-based access control, teams, higher governance with policy controls in terms of what operations were allowed, or if you need multiple approvals and things like that. So really looking at, as we go through this journey, what are the needs of the individual practitioner and how do we solve those, make that really seamless with Terraform Cloud, up through as you're sort of a larger team. It's not just 1 or 2 people, it's a handful of people collaborating on things. What are the features and capabilities you need to make that work? And now really starting to look beyond that, as you go beyond a small team to a much larger team, what are the set of capabilities you need, right? And so when we talk about the growth of Terraform Cloud, it's been exciting and fun for us to watch. We add almost 5,500, 6,000 new users every month. We're doing over 500,000 Terraform runs on a monthly basis and have a little over 2 million managed workspaces. So it's incredible just to see the growth of the tool really over the last 12 months or so. And I think what's become obvious to us, both in seeing the growth of Terraform Cloud and just from hearing from users and customers like all of you on the call today, is that using Terraform Cloud and really consuming cloud services from HashiCorp is the future you'd like to see, right? And I think the reasons are obvious. I'm sort of preaching to the choir here. But it's really around that increased velocity. How do you get out of the business of having to run these kind of services? It's lower overhead, right? And it's reduced downtime because we can staff, a full SRE team to make sure this stuff is on 24/7, right? So with that, I'm excited to announce today the Terraform Cloud Business tier. And this really continues on that journey of adding new sets of features and capabilities to allow us to go from individual user to small team to much larger team. I think that's what this is really focused on, is how do you enable those larger teams to be successful in Terraform Cloud, right? And so this is really a few different pieces to this. One is a set of new enterprise features that we'll talk about. Another is an ability to continue to scale on it, right? So moving past some of the limitations that existed previously, as well as introducing more business grade support tiers. So the first of these new features is a single sign-on capability, starting with Okta as the first one for sort of a seamless experience, just based on customer demand. And so you can see a little bit of a screenshot here previewing what that looks like. As you sign into Terraform Cloud, you can select the single sign-on option, enter the name of your workspace, and then that will trigger sort of the correct workflow to go through Okta, do the sign-in, and redirect back into Terraform Cloud. And so this makes it very easy for organizations that are already leveraging as a centralized identity provider to not have to deal with manual account creation and onboarding and offboarding, right? You can set up your Terraform Cloud account once, link it to your IDP provider, and then have a centralized way of doing identity management. In the very near future, we'll be expanding the Okta support as well to introduce, custom SAML as well as ADFS, and we'll continue to build out that integration for, as customer demand pushes us towards the common providers. The next big one is audit logging. So for customers that are, regulated and have a need to have longer periods of audit that allow them to really be able to do forensics and compliance, this capability allows us to expose basically fine-grained behavior that's taking place within Terraform Cloud and to export all of that to Splunk. So you bring your own Splunk account, you link it to Terraform Cloud, and then all the events that take place in Terraform Cloud get streamed out in near real time out to Splunk, right? So this not only gives you dashboards within Splunk that give you visibility, but it also gives you fine-grained audit capability to go in and do forensics and compliance as needed, right? So this gives you data tracking, gives you finer visibility, and really the focus is on enabling those compliance requirements. And over time, we'll focus on expanding out and allowing, API access to export audit logs to other systems as well. So fixed IPs for ingress. This is sort of a neat one, which is if we think about the goal of Terraform, it's to enable you to plug in all of these different, vendors and solutions you're already using into it to enable those kind of workflow integrations, right? So we talked about version control before and CI/CD systems and ITSM, et cetera. One of the common challenges we've heard from larger customers is if they're running those solutions on premise, they need to explicitly authorize which set of IPs they're allowed to egress traffic out to, right? And so traditionally, this has been a little tough for Terraform Cloud because we didn't publish a set of static IPs for ingress. Now we do provide a set of fixed IPs that you can use so that if you have things on premise or if you have firewalls that are being used to manage egress traffic, now you can do an explicit authorization to which endpoints Terraform Cloud should be allowed. And now you can still link all of your favorite tools in with Terraform Cloud and have those static authorizations and have a stronger sense of control, right? The next one, and this is probably one of my favorite feature that we're introducing, is self-hosted agents. So Terraform Cloud traditionally would run Terraform, as part of of Terraform Cloud, within our infrastructure for you, right? So if you're using Terraform Cloud, you don't have to worry about running Terraform. All of that execution is taking place sort of server side. And so you don't have to worry about making sure that you have somewhere to run it and things like that. And we keep Terraform up to date and secure the environment and deal with that for you. Now, the challenge with that has been, what if I need my Terraform to talk to an API that's not publicly available, right? That architecture works fine if I'm talking to AWS, Azure, Google, et cetera. But what if I need to talk to a vSphere cluster on-premise? What if I need to talk to an F5 big IP device on-prem, right? There's a whole set of APIs that for various reasons we wouldn't want to expose to the public internet, or we wouldn't want to punch a hole through our firewalls. So what self-hosted agents let us do is you can actually run an agent on your own private network. This could be on premises, right? If you needed to talk to a physical device, right? A big IP device. It could be a private network in cloud, right? If you had a private API, you wanted to talk to your Chef server or Puppet server, and it's behind your firewall inside of VPC, great, you can run the self-hosted agent there as well. And the self-hosted agent will basically register back against Terraform Cloud. And so you can set it up in such a way that you say, for this set of workspaces, if Terraform needs to execute, it should run it through my self-hosted agent. So it shouldn't execute it sort of centrally within Terraform Cloud. It should run it on one of my hosted agents. And so this allows Terraform Cloud to still be the central control plane. We can manage all the state and manage all the scaling and all that for you and keep it up to date. But you can run a small component on your private network that allows you to still, deal with the kind of limitations of, these network barriers, right? So very, very excited about this capability. I think this opens up a whole new set of use cases and makes it a lot easier. These agents themselves are very lightweight. It's just a single Docker container that, you can run however you want, wherever you want. The next one is increasing the concurrency. So by default, Terraform Cloud, which really looked at individuals and small teams, provided a fixed set of concurrency. There was only so many Terraform applies we allowed to take place at the same time. Now with the new Terraform for Cloud business tier, this is a customizable number, right? So as your organization grows and you need to be able to make more changes concurrently, that's something that you can simply provision and add to your plan, and we can continue to scale the amount of concurrency available to your organization. So if we talk about the different tiers, right, we introduced, last year was this free tier really focused on individual users. How do we make state management and that basic collaboration really easy to get up and running and make it, so one less thing you have to worry about in terms of how do I manage state, how do I, work with my peers. Then beyond that, as you move to, smaller teams, how do I bring in some of that governance capability, right? So team-based, role-based access control, policies, basic governance, increasing the concurrency a bit so that, for these larger teams, we're not bottlenecked. And as we get to larger teams, that's really where the Terraform business tier comes to play in terms of providing these additional capabilities that we just talked about. So at this point, I'd like to turn it over to Kyle, who's going to give us a live demo of some of these capabilities.
Fantastic. Thank you very much. Let me share my screen real quick and remove the Zoom video. There we go. So what we're going to be walking through right here is a Terraform Cloud organization that has been set up with Terraform Cloud's new business tier. Now for this environment, I'm behaving as a Terraform Cloud administrator, being tasked with, basically taking in all of the teams that my organization has, my company has, and integrating them into Terraform Cloud. Now, there's always been a little bit of complexity around how we manage users. When it comes to user onboarding, they have to create their own account. They have to do this other thing. They have to get me some of those permissions, or rather their accounts, so that I can assign them the appropriate permissions. Well, as part of the new single sign-on integration, we can remove that process and really streamline not only my life as I control and manage the user lifecycle within Terraform Cloud, but also for our users and our practitioners that need to make use of Terraform Cloud. So let's walk through the setup process really quick. Super simple. It's very limited. Within the Terraform Cloud console here, we just need an Okta metadata URL. So we're going to jump off over here to our Okta admin portal. All we need to do is click on this shortcut for add applications. There's already an integration that's out there and available called Terraform Cloud. Click on that, add it to our environment. All we need to do is give it a name. In this case, I'm going to name it after our Terraform Cloud organization. And click done. From that point, we're on the search for our metadata URL, which is located under sign-on underneath our SAML2 configuration. So we'll go ahead and copy that link and return back to Terraform Cloud, paste it in, save, and then now Terraform Cloud and Okta are going to do all the difficult work of setting up this integration. So we can see it's already populated some of the more complex URL strings for both Terraform Cloud as well as Okta, and it's even done one of the things that I kind of don't enjoy doing a lot, which is certificate management. All of that's handled for us as part of the integration with Okta. One thing that I do want to call out here that's extremely important for those folks who are managing Okta within their environments is this member of attribute down towards the bottom. And what this does is this assigns our users, either by groups or individual users, to teams within Terraform Cloud. So with that, we're going to click enable, and then Okta's set. We're ready to roll. We can now start assigning users. So we're going to go back to our administrator portal here, and we're going to assign a user. Now we have a particular user that looks very familiar to my user account, and they belong to the Azure team. So they need access to some of the Azure resources that are out there living in our Terraform Cloud environment. So we've now assigned them to that grouping, to our Terraform Cloud instance. And if we go back up to the top and click on our My Apps option, we now have a new application through Okta that's assigned to us. All we need to do is click on that application. It handles the integration pieces for us. And all we need to do is link up our account if we already have one that's pre-existing. By clicking sign in, it takes us to our organization page where I'm logged in as that Okta user. And now I can see our Azure related resources and workspaces that have been deployed in our Terraform Cloud organization. Really cool, fairly quick to set up and integrate, and we're up and running very fast through that one simple Okta app for our consuming practitioners. However, this kind of has evolved. So our cloud services users and practitioners and users of Terraform Cloud have been talking about it amongst our office on Slack channels and everything, and they're starting to make our on-premises teams a little jealous about what they can do with Terraform Cloud. And since Terraform Cloud doesn't really have a way to reach into, say, our on-prem environments, they haven't been able to use it. So let's check out how we can, simplify some lives for our on-premises environment by taking a look at a vSphere environment. And we're going to try and deploy this template. Me as the Terraform Cloud administrator, I want to make sure that this works and this functions, and it's going to meet the needs of our vSphere team here. So we've already pre-built out a workspace. I'll go ahead and queue the plan up to run while I'm kind of explaining what it's going to do. This is simply a configuration that connects to a vSphere environment, clones that template, and customizes it in accordance to our configuration file. And so this isn't smoke and mirrors. Right now, as of this version, it cannot talk to our on-premises vCenter server. So what we need to do is, we heard about these Terraform Cloud agents from Armon just a second ago. So let's go ahead and set those up. By going to our organization settings and looking at the agents section, we can see how we can deploy that Docker container or even a Linux-based binary. All we need to do is get our new agent token. So in this case, we're going to name it something appropriate, such as vSphere. Now we have our token, and I already have a Docker container that is local. Look for this to be out on the Docker registry in the near future. However, now that we have that, we have to set two environmental variables. One is a requirement, that's the agent token that I just received. The other one is an agent name, and that's what tells us, in the Terraform Cloud UI, what the agent is, or at least a little bit of more information about what's running. So if we click done, our agents section here has updated. We can see that we have a pool name by default, and we're currently in a state of waiting for agents. So if we jump over to our terminal session here, and actually let me pull out my cheat code here, since I'm referencing that environment list. Just performing a simple Docker run, we can see a couple instances here. We see our agent name. We can see that we have successfully registered with Terraform Cloud, and we have an agent ID. At this point, down here towards the bottom, it's starting to check in with Terraform Cloud, meaning that we don't have to configure any firewall rules. We don't have to do anything like that for our on-premises environment, nor any of those network segmented environments. So this is all set, we're running. We can go back to our Terraform Cloud environment. We can see that the agent has registered, so we're ready to go. So let's head back to our workspace here. Actually that's gonna not work. I need to change one more thing. So another new thing that's as part of this that you have to configure on your workspace is the execution mode. So previously you had remote execution, meaning that Terraform Cloud basically ran all of the Terraform-based operations on our behalf. And we had local mode, meaning that we ran it from Terraform from the local CLI, and then Terraform Cloud managed the state in all of our configuration files. Now we have a new one called agent. And this is the one that tells our workspace to reach out to that Terraform Cloud agent in order to process that task. So we're going to queue up our plan here, and we're going to bring back our Docker container that's running our Terraform Cloud agent. We can see on the right-hand side, it's already starting to pick up some information. So we can see the output of our plan saying that we're adding one new virtual machine resource based on that cloned configuration. Then this switches off and runs through and should be asking us to confirm. There we go. There's our confirm and apply. So now we can start deploying this template within our vSphere environment. So we can see our Docker container over here on the right-hand side is kicking off. There it goes. And we see a new temp VM deploy virtual machine that is being deployed right now. We can see that the clone operation is happening based off of that template with our service account for Terraform that was configured through the on-premises Active Directory instance. So really cool, amazing being able to reach into this environment. However, now we kind of have a problem because that one agent is running, and this task is going to take at least 7 minutes, maybe 8 minutes, depending on how the backend storage feels at this point in time. So now our AWS team, our Azure team, and now our vSphere team are waiting for this task to complete. This is where another feature that's built into Terraform Cloud in the business tier comes into play, and that's being able to run multiple jobs concurrently. So our vSphere team has another need to stand up a brand new environment, and they have a folder structure that they need to implement. So in this case, they're going to run or create an environment that's within the Tampa region, since that's where I live. However, they don't want to use Terraform Cloud for whatever reason to kick these off. So we're actually going to use the CLI instead to do this. So while that's running, let's open up a new terminal session here, change over to where our GitHub repo is, and let's do a Terraform plan. So at this point, we haven't yet configured that execution mode, so it should error out even though we're running Terraform, the CLI, from our local on-premises environment. So we do have to go back to our Terraform Cloud console, connect into our workspace, modify that execution mode, click save, and now we'll just skip the plan and go right to apply for the sake of time. So up top, we can see our virtual machine is still deploying. It's been going through that process for about 2 minutes now. And then, oh, wait, I need to deploy our new agents. That's why it's going to wait. All right, so the other part of this situation is currently right now I'm running this Docker container, this agent on my local machine. And that's not very environmentally friendly. That's not very, it doesn't scale well. So we're going to use instead Nomad to now kind of orchestrate the process with our Docker containers here. So I have a sample Nomad job that's configured here. We're going to set it up to have 2 different agents that are out there. And I need to copy in my token real quick. Yep, let me make sure I get the entire token here. So there's that. And then also I want to call out, as part of our Docker configuration here, we're not setting up any mapped ports. This is completely an outbound transaction. So, continuing that whole thread of no firewall ports being necessary. So we're going to toss that into Nomad. We have our successful setup there. Then we click run. So now at this point, it's going to go out. It's going to start running those Docker tasks. So we can see there's one that's already running. And if we click through that, we'll be able to get to our logs. So here we can see that verbose log output from the debug configuration. It's reached out, it's talking to Terraform Cloud, and it's ready for jobs. Now, if we jump to the other one real quick, because it should be waiting on that folder process. All right, so both of those are running. Let's check back in on our Terraform Cloud agent. There we go. Both of those are now authenticated into Terraform Cloud. We can see that they have different agents, Terraform Cloud agents and Nomad. And let's go back to our terminal session here. So we've already actually applied the configuration here. It ran through extremely quickly. So let's see if we can pick off which one of these. Oop. Anyways, we'll go to our vSphere environment here. We can see that it created a bunch of these folders again, under that service account, all while our clone is still happening, is still going through that process. We even have nested folders, so we have the different services and the entire process. So now we've gone through, we've configured this for some on-prem usage as well. However, it's starting to scale out, and there's a lot of things that are now happening in this environment, and it's important to have good visibility and a good understanding of your environment as a Terraform Cloud administrator. Plus, the security teams kind of like it when you have a good understanding of the logs, being able to pull those back. It helps with compliance and other things along those lines. So what we can now do is built into Terraform Cloud is the ability to pull back these audit quality logs. So when we look over here onto the settings page, there's nothing to configure there. So this is something that's there automatically. So what as part of this, of what it's doing is it's presenting out a new API service called Audit Trail. Let me switch over here so we can see, we can do just a sample curl statement out to Terraform Cloud instance. All this is looking for right here is this token as far as the authentication process is concerned. Let's go back to terminal session here. We'll just run this in our bottom. So here we have a bunch of logs that were returned. I'll go up and grab some of these just to kind of show you what's happening in here. And we'll use Visual Studio Code to format our document so we can kind of read it a little easier. So here we can see that this is a paginated API structure. We have about 100 different logs on a single page. This continues rolling out for this instance, there's 1,288 different audit logs. So you can see some of the things that are happening in here. We have a state version being read. We have, let's see if we can find something fun. There we go. We found Sentinel, the policy as code framework that was checking against a configuration and making sure that it was configured in accordance to our best practices. And we can see that it was my user account that was actually running that. We can see some other things like a planning action that was taking place. But this isn't really friendly as far as being able to interact and interpret these logs. So what we've done is we've built an integration with Splunk to allow us to better be able to understand what these logs are coming in and be able to start querying them as well. So let's log into our Splunk instance here. Now, I believe as of about 30 minutes ago, the application showed up within Splunk environments for you to download automatically. For the sake of this demonstration, I've already preloaded our Terraform Cloud for Splunk application. Now, all you need as part of this is an organization token. So once we click to get to the setup page, we have an input name and an organization token. Let me jump back over to our API tokens, regenerate our token, and head back to Splunk here. We're going to continue to use our organization name for the sake of input. Input our token, complete setup. And after just a couple seconds, Splunk is going to reach out to the Terraform Cloud API service and start pulling back some of those logs. So far we can see 83 different events that have been pulled in from the last just 27 minutes. So if we go out and go ahead and search for, there we go, my user account, we can already see that some of those tasks have started to populate in and come through. But we want to get to the point where we actually have some good understanding, some good visualization as to what's going on in our environment. So we have two new dashboards that are out here. It's just a light theme and a dark theme, but it helps visualize all the things that are happening within our Terraform Cloud environment. Now, this Splunk instance is going to continue to populate all the information as it goes. So as of right now, it has enough information to know that we've applied 10 runs in last I saw in the search area was in the last about 30 so minutes. We have 184 different resource operations. We can see all the occurrences filtered by time. We can follow some of the built-in pieces with Splunk to filter out against all time, last hour, and all the other different time frames. And we can see some of the different occurrences that are happening. And down at the bottom, we can continue to filter through this even a little more. So we can see the individual runs, some configurations, and so on. Let's see if we go back to our, see if it's loaded anything else. Nope, still pulling information. So with that, I'm going to turn it back over to Megan, as we've covered a great walkthrough of kind of some of the really new features for Terraform Cloud's business tier.
Yeah, great. Thank you, Kyle, so much. And thank you, Armon. You both did an excellent job discussing the new announcements to Terraform Cloud. We had quite a few questions come in, and the team is working to get all of them answered through the Q&A, but I'm going to take a couple of them that were kind of popular questions and have Armon and Kyle answer those live as we finish up today's announcement. All right, so the first one I will have for Kyle, and it will talk about self-hosted agents. And do self-hosted agents need to have any ports exposed to public internet? And this is something that I've heard come up quite a bit as people think about the security of their on-prem infrastructure.
Yeah.
Kyle,
So
do you want to take that? Yep.
Yeah. So for the Terraform Cloud agents, it's really great because there are no real requirements as far as port-based security. As long as your internal resources, or from whatever network segment that you're running these, as long as they can reach out and hit the internet, and in particular the if you have any sort of approval lists, URL-based approval lists, you can do just app.terraform.io. As long as these agents can reach that, you're good to go. So there's nothing that you really need to apply to your environments. There's no ports that you need to open. The communication does go over port 443. So if you do happen to be monitoring your network activity, you're going to see some transmits over port 443 from that agent.
Great, thank you, Kyle. All right, so Armon, I'll have you answer the next one. And this question actually came in quite a few times. So it sounds like everyone's really excited to see Terraform Cloud will offer SSO. And the first integration was Okta. So we had a bunch of people ask how soon could they expect to see SAML and ADFS coming, even if it's just like a rough time frame.
Yeah, we don't have an exact date, but I think our goal is over the next quarter, we'll have both generic SAML support. So that'll let you plug in with basically any IDP, as well as a more tightly integrated ADFS integration. So both of those should be available in the next quarter.
Great. So for anyone that's interested, if you wanted to get started with the Terraform Cloud account, you could go get started now. And then once the integrations come available, you could definitely reach out to our sales organization to get set up with that. All right, so Armon, I'm going to actually have you take the next one as well. So as some of these users and organizations are looking at using Terraform Cloud, they wanted to understand a bit more how we think about the reliability of the platform, Terraform Cloud platform, and just addressing outages.
Yeah, it's a great question. I mean, I think we are keenly aware that, with any cloud service, operational excellence is sort of top of mind for any user. So we've made pretty large investments both in our security, our operations, and our SRE teams, right? So we now have, a fully staffed security team that does, white box and black box testing, as well as active, proactive application security engineering with our teams to make sure the platform is secured and that we're finding vulnerabilities and closing them before anyone else does. We have a full operations and SRE team as well that's designed to provide, 24/7 coverage of the service. So one of the pieces that's coming with the Terraform for Cloud business tier is a committed SLA that actually has a financial backing, right? So we are actually committing to a particular SLA, and there's sort of financial credits and repercussions for us not hitting that. So we're very much aware that this is a top of mind issue for folks, and we're heavily invested to make sure that it's a super reliable and secure service.
Great, thank you, Armon. All right, Kyle, we have another question about the self-hosted agents. The question is, are we able to tag the self-hosted agents such that certain agents would be used for a certain Terraform workspace?
So as of today, like literally with this release, that is not something that's going to be available. What happens is it goes out, it creates a single pool and allots all of those agents to that pool. Now that is something that we understand that might be a limitation for certain environments. So we are looking at being able to create multiple pools. So in that case, we can start applying different pools or different agents within pools to specific workspaces to help accomplish or help accommodate some of those situations where you have multiple networks that may not have access directly to Terraform Cloud. So that is something that we are targeting towards adding to the service, but it is not there as of today.
Okay, great, thank you. All right, Armon, so the next question is about the differences between Terraform Enterprise and Terraform Cloud from a capabilities perspective and just parity between the two. So maybe we could talk about parity between the two and just maybe who would be someone maybe still interested in self-hosting versus using Terraform Cloud.
Yeah, I mean, I think at the highest level, the biggest distinction between them is very, very different operating models, right? Terraform Cloud is itself a multi-tenant SaaS, right? So we operate a single global region of it. Many customers tenanted on it with different, features and capabilities, depending on what tier they're in. Versus Terraform Enterprise is a single tenant offering that is self-hosted, right? So you can run that yourself on a few VMs, whether that's in a cloud account, and you might run it there, or you might run it on premise. You can run it fully air gapped from the internet. It doesn't need to be, it's not connected back to us in any way. So two very, very different operating models in that sense. I think folks that tend to be interested in Terraform Enterprise have a need to run it on premise. Maybe that's driven by compliance. Maybe that's driven by they're not yet operating in a public cloud setting. Or maybe it's because of security requirements, they're more comfortable with that sort of single tenant on-premise operating model. From a features capability perspective, very close parity between Terraform Cloud for Business and Terraform Enterprise. So less about feature differentiation, more about what sort of operating model do you need, and does your organization require the ability to run it air gapped potentially. So I think that's probably the biggest distinction, and our expectation is most customers will be able to use Terraform Cloud for Business, and given that it has all the same capabilities, and it's a much simpler operational model if you don't need to run it yourself.
Yeah, great, thank you, Armon. I'll actually have you answer the next one. Does HashiCorp have any plans to extend Terraform Cloud to allow the user to choose the region their data is stored in or processed in?
Yeah, it's a good question. So I think, from a perspective of where Terraform gets executed, Terraform Cloud, the self-running agents now give you an option to run those wherever. So if you want to localize Terraform's execution somewhere else, you can do that. The control plane itself, Terraform Cloud for now, is single region. We don't have immediate plans to support other regions. It's definitely something we're thinking about in terms of various approaches, whether that is adding additional regions that you can choose to home your data in, or if we solve it through a different, more sort of a bring your own key type of a mechanism. So there is kind of product exploration in terms of how do we address that customer requirement? Because we hear you, we know there's folks, whether in the EU or parts of Asia that have these other requirements. So we definitely understand those concerns, but today it's either solving that through Terraform Enterprise, which can be self-hosted in a different environment. If the Terraform runners meet your capability, meet your requirements, then great. And then otherwise, we're sort of continuing to have that conversation with customers on how we can solve the distribution problem for the control plane itself.
Great, thanks. Thank you, Armon. All right, so it looks like we may have time for one or two more. So Kyle, this one is about the fixed IPs. So a lot of people are really excited to see those to help with various different use cases. And the question came in, can those fixed IPs also be used to secure ingress as well? So in other words, will traffic from Terraform Cloud appear to come from those IPs?
Ooh, that's a good question. I actually don't know off the top of my head.
Yeah. All right. Armon might know. I think he actually had a chance to answer this question.
You know, I'm not actually quite sure either. I don't want to.
Or trick question. Yeah, it looks. So we had some help from some of our engineers on the back end answering these questions. So they said, yeah, that's what we hope to enable with these IP endpoints. You'll see where our traffic is coming from and exactly what service is being provided from that traffic. This will let you make informed decisions about what to allow and to where. So there we go. Thank you. We have lots of help on the back to get all the questions answered, so thank you. So I think that was all the questions I had that were pretty top of mind or popular. I think if anyone is looking to get started with Terraform Cloud, you can certainly go to app.terraform.io and sign up for a free account today and get started with all of the free capabilities to create and share and manage the infrastructure. And if you're already a Terraform Cloud user or you are interested in the business tier, you can always reach out to the HashiCorp sales organization and they would be happy to set you up with trials or discuss signing up for that option as well. And with that, I think we will be wrapping up today's webinar. Again, the recording will be made available within two business days once the post-processing has been complete. So thank you everyone who submitted the great questions and for our speakers today for participating. I hope everyone enjoyed today's live stream and the newly introduced Terraform Cloud business tier. To get started again, you can go ahead and sign up at app.terraform.io or contact a HashiCorp representative at hashicorp.com, contact sales. You can get started with Terraform Cloud by creating that free account on the app, like I said. Finally, as mentioned at the beginning of this live stream, we'll make the recording available after post-processing. Thank you everyone for joining and have a great day.
Thanks everyone.